Hi everyone, in this video we will learn how to perform common math computations on tensor segments. Firstly, let's say we have this one-dimensional tensor. Now we should divide this tensor into groups. And to make these groups, we should know what the size of the first dimension of our tensor. And as we mentioned before, this tensor is just one-dimensional tensor. The size of the first dimension, which is the only dimension available in this tensor, is equal to the number of elements in this dimension, which is equal to 8 at this case. Now we should create segment ID's tensor, and the size of this tensor equal to the size of the first dimension of our input tensor, which is 8. As you can see here, the size of our segment ID's tensor equal to 8. Now we will use these numbers inside our segment ID's tensor to make our groups. The first three elements in segment ID's tensor are zeros, which means that the corresponding elements are in the same group. The fourth element in our segment ID's tensor is 1, and the corresponding element in our input tensor is 2. And we will create a group here which contain just this element 2. Now let's move on to the fifth and sixth elements in our segment ID's tensor. The corresponding elements in our input tensor are 3 and 4. So we will create a group that contain 3 and 4. We will do the same thing here, and the corresponding elements in our input tensor are 1 and 3. We will create a group that will contain them, as you can see here. Now we will apply math operations on these groups. Let's say we want to add the elements inside each one of these groups. So at this case, the first group here, 5 plus 1 plus 7, the result equal to 13. The second group, 2, which is 2 itself here. The third group is 3 plus 4, and the result equal to 7. And the last group, 1 plus 3, and the result equal to 4. Now let's take the maximum element in each one of these groups. The maximum element in the first group is 7, so we will put 7 here. And the maximum element in the second group is 2, because there is just one element in this group. The maximum element in the third group is 4, so we will put 4 here. The maximum element in the fourth group is 3, and we will put a 3 here. And we can also take the mean for each group. Let's say we want to take the mean for 5, 1, and 7. 5 plus 1 plus 7 divided by 3. So the result equal to 4.3. The mean for this group is 2 itself. The mean for this group is 3 plus 4 divided by 2, and the result equal to 3.5. The mean for this group is 1 plus 3 divided by 2, and the result equal to 2. And we can also take the minimum number inside each one of these groups. So the minimum number of the first group is 1. So here we will put 1. The minimum number in the second group is 2 because there's just one element here, so we will put 2 here. The minimum number in the third group is 3, and we will put 3 here. The minimum number in the fourth group is 1, so we will put 1 here. Lastly, we can take the products along the segments of our tensor. So the first group, 5 times 1 times 7, the result equal to 35. The second group, 2, which is 2 itself. The third group is 3 times 4, and the result equal to 12. The last group, 1 times 3, and the result equal to 3. Now, we built this tensor which has 2 dimensions, row and column dimensions. Firstly, we should know what is the size of the first dimension of our input tensor. So x.shape 0. The result is 3. So the size of segment ID's tensor should be 3, or we should put 3 elements in segment ID's tensor. Let's do it. Firstly, let's type segment ID's tensor equal to tf.constant open parentheses. Here we will put 0, 0, 1. These elements mean that we will create 2 groups. And because we are dealing with the first dimension, which is row dimension, so each element in this segment ID's tensor corresponding to 1 row in the input tensor. So 0 here corresponding to the first row, and 0 here corresponding to the second row in our input tensor, and the 1 here corresponding to the third row in our input tensor. The first group will contain the first 2 rows in our input tensor, and the second group will contain just the third row in our input tensor. And that's what we mean by 0, 0, 1. Now let's apply segment.sum method from tf.math module. So we will type tf.math.segment sum open parentheses. There are a set of arguments in this segment sum method. The first one is data, which is equal to the input tensor, x. The data type of our input tensor should be one of the following data types. The second argument is segment IDs, which is equal to segment ID's tensor. This tensor should be one-dimensional tensor, and the data type of this tensor should be integer 32 or integer 64. So you should put integers here. We can type here d-type equal to integer 32 or tf.integer 32. Let's see the results, and here's the results. It's just 2-dimensional tensor. The data type of this tensor is float 32, which is same as the data type of our input tensor, float 32. As we said before, there are 2 groups in this tensor. Here's the first group and here's the second group. Firstly, let's add the elements of the first group together. element wise. So 1 plus 5, the result equal to 6. 2 plus 6, the result equal to 8. 3 plus 7, the result equal to 10. While the second group will be the same here, because there are no any other row in this group. Now let's apply segment max and see the result. And here's the result. We will determine the maximum numbers between these two elements or rows in this group. So 1 and 5, the maximum number is 5. 2 and 6, the maximum number is 6. 3 and 7, the maximum number is 7. And because there are just one row in the last group here, so we will put this row itself, 4, 7 and 5. The data type of the output is float32, same as the data type of the input, and the shape of the output is 2, 3. Now let's use segment mean and see the result. Firstly, here's the first group. 1 plus 5, the result equal to 6, divided by 2, the result equal to 3. 2 plus 6, the result equal to 8. 8 divided by 2, the result equal to 4. 3 plus 7, the result equal to 10, divided by 2, the result equal to 5. And the last group, we will put the last group itself here. Let's try minimum. And here is the result. Here is the first group, 1 and 5, the minimum number is 1, we will put 1 here. 2 and 6, the minimum number is 2, we will put 2 here. 3 and 7, the minimum number is 3, so we will put 3 here. The last group, we will put it here itself, 4, 7 and 5. Lastly, let's try product or a segment product method. Let's see the result. We will multiply the elements of these two rows element wise. So 1 times 5, the result equal to 5. 2 times 6, the result equal to 12. 3 times 7, the result equal to 21. And the last group, we will put it here itself, 4, 7 and 5. Thanks for watching.